Okay, so this is action code D. We're dealing with chemical formula and balanced equations, and this takes in a couple of statements from your specification. Okay, so statement F here, how to write a formula of ionic compounds given the formula of the ions they contain. There's a little bit of that in here, and also there's a little bit of how to represent chemical reactions using balanced chemical equations, okay, where the total relative mass of reactants and products is equal. So it's the balancing of equations bit that we're interested in here. Okay, so this first one, there are a couple of subtleties that we need to worry about here. So if we have a look at a formula table, a common ions table, we've got a couple of choices to make. Okay, so it doesn't matter which choice you make. So for the first part, we need to write out a chemical equation. Okay, so for aluminium, it's Al. Okay, we could add the state symbol, which is an S, but we'll keep this simple for now. So the choice we have to make is iron oxide. If we have a look at our formula for some common ions, we've got a 2+ and a 3+. Okay, now as the question doesn't specify which, it doesn't matter which one you do, so I'll do Fe2+ first. So iron oxide, if it consisted of Fe2+, and you combine that with an oxide ion, okay, which is O2-, then the formula would be quite straightforward. It would be simply FeO. If we then moved on to aluminium oxide, then aluminium is Al3+, and oxide is O2-, and so to get a formula with no overall charge, we would need 2 aluminiums and 3 oxides to make sure we had a 6+ and a 6- charge. So that would give us the formula Al2O3, and then iron obviously is Fe. Okay, and then if we set up the boxes method, so we've got aluminium is reacting with FeO to make Al2O3, so that's Al, O, for that Christmas. And then we've got Fe. So if we look here, we've got 1 aluminium and 2 aluminium oxides. So let's stick in an extra aluminium. And then we've now got 1 iron and 1 iron. That's okay. However, we've only got 1 oxygen and 3 oxygens there. So what we need to do is add in another 2 FeOs. By doing that, we've got 3 oxygens to balance those oxygens. We've now got 3 ions on this side and only 1 on that side. So we need to add in another 2 Fe's, or 2 ions. So now we should have a balanced equation. There are 2 aluminiums, 3 ions, 3 ions, 3 oxygens, and 3 oxygens. So we transfer that information over here, and we'd have 2, then we'd have 3, then we've just got 1 of those, and then we've got 3 of those. Okay, so that's one option. For the second option, I'll use a separate sheet and room. So this time, instead of using the iron 2+ ion, we use the iron 3+ ion. So the same again, aluminium, except this time, if we use the Fe3+ ion, okay, so this one here, then we'd need 2 of these to balance 3 of these. Okay, so 2 times 3+ is 6+, and 3 times 2+, sorry, is 6-. So that would give us the formula Fe2O3. We've already seen that aluminium oxide is Al2O3, and the iron is Fe. So again, if we adopt the boxes method, we've got aluminium, bigger box this time. So we've got Fe, O, and here we've got Al, O, and we've got Fe. So this time we've got 1 aluminium there, but we've got 2 here. So we need to add in an extra aluminium. We've got 2 ions here, and 1 here. So if we put an extra iron there, that makes life better. We've got 3 oxygens and 3 oxygens. Okay, so this one balances a little easier. So we need 2 aluminiums and we need 2 irons. Okay, so that's 2 alternative ways of doing this particular equation. This next one, as I think I mentioned in the lesson, I made an error here. This could either be copper oxide or this could be hydrogen, but the correction I made in lesson was to tell you that this should be hydrogen. Okay, I took one equation and forgot to adapt it. So nitric acid is one of the acids you need to be aware of generally. It was one we came across earlier in the term. So nitric acid is HNO3. Copper is Cu. Copper nitrate, we need to have a look at the formula list again. So copper is around here somewhere. There we are, copper 2. There's only one form of copper shown here, so it's a 2 plus. The nitrate ion, okay, is NO3 minus. So we need 2 of those to electrically balance one of those. And because this is a compound ion, we would need brackets around it to put the 2 after. Okay, so copper nitrate would be Cu, open a bracket, NO3 twice, because we need 2 nitrates to electrically cancel out 1 copper. And then hydrogen is H2. So if we draw this as the box method, we've got a H, an N, an O, O, O. And we've got copper, which is Cu. Then we've got, so you've got to be careful with this one, okay, because it's got the brackets. So we've got 1 copper, and then we've got 2 nitrogens and 6 oxygens. So careful to get 6. And then here we've got H. So we've got 1 hydrogen on this side, okay, and we've got 2 on that side. So the only way to balance that would be to add in an extra nitric acid. Can't just throw in random atoms. That balances the hydrogens. We've now got 2 nitrogens, okay, which is handy because we've got 2 nitrogens here as well. We've got 6 oxygens, which also works because we've got 6 oxygens there. We've got 1 copper and 1 copper, okay? So by adding that extra nitric acid, we've managed to balance that equation. Okay.